This is the presentation entitled Negative Binomial Distribution for Explain Spatial Distribution of Águila Cholchol in Northern Chilean Patagonia by Patricio de los Ríos-Escalante from Biological and Chemical Science Department, Natural Resource Faculty of the Catholic University of Temuco, Chile. As introduction, Águila genus is an endemic inland water decapod that inhabits South American lakes and rivers, and it had an important key role in feeding of the water, and it is an important prey of fishes, mainly introduced salmonid and predator fishes. Águila genus inhabits in benthic environment, and its spatial distribution is variable in function of bottom composition, food availability, and predator exposure, and it can be uniform or aggregated distribution. The aim of the present study is analyze the spatial distribution patterns of Águila Cholchol population in Cautín River close to Temuco, in Chile, North Patagonia. As material and method, first in study site, the study site was a beach in Cautín River in Cajon town, close to Temuco, in 38 degrees 45 minutes south latitude, 72 grade 40 minutes west longitude. The site was visited in 2006 January and February, 2012 March, and 2022 in September. It was done a non-destructive sample using a silver net of 50 by 50 centimeters, 100 mesh size, in littoral zone of the study site. Águila Cholchol was collected and counted and released to the river, and to obtain a date was estimated mean and variance. For obtaining the information, it was estimated variance mean ratio with the aim of determining the spatial distribution pattern of studied organisms. It was associated, uniform, or random. First, we registered the number of individuals for each sample, and then determined the variance and the means of each samples, and a way for determining the spatial pattern for the species. So, if the variance mean ratio value is 1, the distribution pattern is random, whereas if the variance mean ratio is lower than 1, the distribution is uniform, and finally, if the variance mean ratio is greater than 1, the spatial distribution is aggregated. Once it was obtained the variance mean ratio, data was examined using Poisson binomial or negative binomial distribution as an appropriate probabilistic models of the spatial distribution patterns, results obtained by variance mean ratio. If the first analysis denoted associated pattern or uniform or random spatial distribution, a second step analysis was applied with the negative binomial, positive binomial, and Poisson distribution respectively, and this analysis was applied using Excel-Stat software. In result and discussion, we revealed that Águila population has an aggregated pattern, and it used the negative binomial distribution. You can see the results in this table. In this slide, you can see the graphs of expected and observed frequencies for each population in the 4th sample period, and you can see that the negative binomial distribution has a very good adjust in for all studied period. At discussion, the exposed result revealed the existence of negative binomial distribution for studied population that can be an adaptive strategy for optimizing the food capture and protection against predation. Similar results has been noted for Patagonian inland water and intertidal decapods, as well as intertidal decapods in north of Chile, parasite and ectocommensals. In this scenario, the negative binomial distribution can be a robust probabilistic model for explaining spatial distribution of species that have aggregated patterns. Finally, this is the important contributors for this study and the important reference that were based in this study. Thank you for your attention.